Now we're looking at converting between polar and rectangular coordinates. So before we get into the actual conversions, I want you to remember some things from trig. So x squared plus y squared, that's going to equal r squared. So it's just a Pythagorean theorem on the triangle. Tangent is going to be y divided by x. So if we have this situation here in this triangle, we have a x value and a y value. If we're looking for this coordinate here, here's a theta, and we have a radius or a hypotenuse in that situation. So that's where your x squared plus y squared equals r squared comes from. That's just the Pythagorean theorem. Tangent of theta, we know that's opposite over adjacent. That's y over x. And then if we look in here, how would we find x? Well, that's going to be the sine of theta, or sorry, x would be cosine of theta equals x over r. So we can say that x equals r cosine. If we're looking at the y, that's going to be opposite over hypotenuse. That's going to be sine. So sine of theta equals y over r. So if we multiply both sides by r, we're going to get r sine. So we need to know these equations. So these are things that we looked at back in trig. We need to know these four so we can convert from polar to rectangular and vice versa. Alright, so change the point 2 pi over to rectangular form. So we're looking at plugging a radius into the equation, and we're plugging a pi in. So we want x's and y's. So we need to keep in mind what that looks like. Okay? So I want an x and a y. So we know what x equals. That equals r cosine theta. So plug in our values. R cosine of theta. Cosine of pi is -1 times 2 would give us a -2. And then we have our y equation, 2 sine pi. Well, sine of pi is 0, so this is going to be 0. So our conversion is -2 and 0. Okay, so that's just one method. The other method deals with the similar to what we did up in these last examples in the last video, drawing a triangle in that position. So we would draw a triangle with a radius of 2, and then we would rotate it to pi and see where we're at. We still would get the x and the y value of -2, 0. So either way you want to do it's fine. You can do the same thing with this next one. I'm going to do it with the equations just because we already covered how to draw a triangle and figure out what the values would be. So change the point to polar form. So now we're starting with a rectangular. We're starting with x's and y's, and we need to find an r and a theta. So think about, if I have an x and a y, how could I find an r? Well, it's this first equation right here, the Pythagorean. So if we plug that in, so -3 squared plus 3 squared equals r squared. So this would end up being r is 3√2. And to find a theta given an x and a y, we could use the tangent equation. So tangent of theta equals, so y is 3, x is -3, so that would be -1. So anything about where tangent is -1, excuse me, tangent would be -1 in the second and fourth quadrant. We're just going to worry about the second quadrant right now. We want to know when it first happens. So theta is going to be, and that happens at 3 pi over 4. Okay, so we know tangent, so we know sine and cosine are the same value at 45 degrees. So we just have to figure out what the associated angle is in the second quadrant, which would be 3 pi over 4. So now our coordinate is 3 root 2, 3 pi over 4. So that's converting points. Now we're going to take a look at converting equations. Okay, so we have a rectangular equation. We're converting it to polar. So we have y equals 4. So if we know y equals 4, what we could do is substitute in our known value for y using our equation. So we know y equals r sine theta, and that equals our 4 that we know y equals. Solve for r, so we get r equals 4 divided by sine. Okay, so how do we know we're done? Well, we know x's and y's are gone because those don't exist in polar, and we have an r and a theta. So that's how we know when we get to where we need to be. So the next one, 3x minus y plus 2 equals 0. So we have to plug in our value for x, which we know is, actually I need parentheses. So x equals r cosine minus our y, that's r sine, plus 2 equals 0. I'm going to factor out an r. And I'm going to get rid of that 2. I'm going to move it to the other side. Oops, I don't need that yet. Too much. Now we just solve for r. So we can divide both sides by this whole quantity here. So we got r equals -2 all over 3 cosine minus sine.